In this video, I'd like to show how to use the numerical derivative tools of a TI nSpire to find information about the derivative and create the equation of a tangent line. So to do this, I'd like to open up a graph page, and I'm going to start by entering the original function. So let's say the function I'm interested in is x cubed minus 4x plus 2. And if I press enter, we see that cubic function. To create a graph of the derivative, the next thing I want to do is create a graph of the derivative. So I'm going to press tab. And then next to the 9, there's this special key that pulls up a menu, so the left side of that key. And I want to choose the D over D box, and then there's a little box there. This is the way to create a derivative numerically. I'm going to type in x next to the D because I'm taking the derivative with respect to x. And then inside the parentheses, I want to reference the earlier function that I defined, the f1 function. So I just need to type f1 and then a parenthesis and then an x. And then if I press enter, we see a second graph that displays the derivative values of the first graph. So initially the first graph is increasing and the values of the red graph are positive. They're above the x-axis. At this peak, the slope of the tangent line is 0 and we get an x-intercept on the red graph. The slopes of the tangent lines become negative because on the blue graph, the values are decreasing until we reach the minimum. At the minimum, again, we have an x-intercept. The slope of the tangent line is 0. So the derivative function crosses the x-axis and then becomes positive exactly when the blue graph starts increasing again, because then the slopes of the tangent lines are positive. So we can see that relationship in the graphs. But what's really maybe helpful is we can open up a second page. This time I want to create a calculator page. So I'm going to press Control Doc and then choose a calculator page. I can reference those two functions and find information about them. So suppose I'm interested in finding the slope of the tangent line when x equals -2. So the slope is going to come from the second function, the derivative function. So if I press F2, and then open up the parentheses, and then enter the x value, -2. So using function notation, the function f2, when x equals -2, the slope of the tangent line is 8, right? This is the derivative function. So it gives me the slope of the tangent line to the original function. The original function was named f1, and to find the equation of the tangent line, I also need to know a point. Specifically, what is the point when x equals 2? So if I type in, when x equals -2. So if I type in -2 as my x value, and then press enter, I see that -2, 2 is a point on the graph. And so now, on paper, somewhere else, you can do a little bit of algebra, use the point slope form to create an equation, and then if we want to graph it, we need to put it into slope intercept form. It turns out the equation of the tangent line has so I can show that a little bit here, but this is going to be a little bit silly, but I can do y -2 minus this +2 equals 8, and then in parentheses x minus -2 from the -2 here, which is actually the same as x plus 2. So that's an equation for the line, but the TI nSpire, this is not a CAS version, so it doesn't really like those variables that are undefined, so it's going to kind of complain a bit if I press enter. But if you imagine, if we multiply out the 8, we would get 8x plus 16, and then I can add 2 to the other side, and I get y equals 8x plus 18. and that's the equation of the tangent line. So to see that, if I go back to my graph and press tab, I can enter in that formula, 8x plus 18, and we'll see a third line on the graph, and that is the tangent line to the blue graph when x equals -2 and y equals 2. So the point on both the blue graph and the black line is -2, 2, right around here, and the black graph is tangent to the blue graph at that point. So just to quickly summarize, let me move this black label if I can. No, it's not liking that anymore. Okay, let me try to grab that and move it. Okay, there we go. So the blue graph is the original function. Referencing that original function f1 and this expression that gives me the derivative, I can create the second function f2. And then in the calculator page, I can reference f1 and f2. f2 gives me the slope of the tangent line, and f1 gives me the y value of that point. The x value I'm interested in is -2. And so taking that y value as y1, I get y minus 2 equals the slope, 8. And then x minus -2 becomes x plus 2. Right? Again, my x value is -2, and it becomes minus -2, which is plus 2. So that gives me my formula. With some simplification, I can create the formula to the tangent line and see that on the graph here. I hope that was helpful. Thanks for watching.